Okay, Ji. Let's start with a new lecture. And previously, we stopped the lecture at the designing of the finite automaton. So now we are going first to learn the definition of finite automaton, and then we will move on further to design some of the FAs, and then we will continue some theoretical stuff and so on, and some theorems and lemmas. So let's start with the definition of the finite automaton, simply called FA. So as you are seeing on the screen, so finite automaton is a finite state machine, and it contains five tuples, as you are seeing, and those five tuples contain q, sigma, q0, capital A, and delta. So q is what? Q is a finite set of states that we will introduce when we finish the designing of a FA. So the total number of states, you can say, and that total number of states in a FA is a finite set of states. So that's why we will represent those finite set of states with Q. And then sigma, you already know that what sigma is. So sigma is a finite alphabet set, and that set will contain some input symbols that we can use to build different strings according to the language. And then Q0 is the initial state of the FA, and that Q0, as it is an initial state, so it means that it is the part of the bigger set, which is capital Q, because it is a total number of set of states for FA. So this Q0 is the part of that bigger set Q. That's why it is written here as Q0 belongs to capital Q. Q0 is what? It is the initial state again. And then A, capital A is for the acceptance state or the final state of the finite state machine. So it is again a subset of the bigger set of states, which is Q. So we can write it as A is um, A as subset of Q, the set of accepting states. So one thing you can remember, that the acceptance states or the final states um, can be more than one. So finally, the delta. Delta is basically a transition function. And delta is a, so we can call it delta is a function or transition function from one state to another. If you have a state in finite automata and you have another state, then the transition from this state to this state is is, you can say, delta. So delta is a transition function from big Q cross product of sigma, which means we have a set of states in big Q, and we have a set of input symbols sigma. So you can take any state and you can apply any symbol, and then you can move on to some other state. So in this way, you can take second state, you can apply some input symbol, and you can go on to further any state of the FA. So that's why it is a Cartesian product of big Q and the sigma. So all possible combination of states and the input symbols. And after applying some input symbol over a state, where you will go, you will reach at another state. So that state is again the subset of bigger Q as you are seeing on this screen. So that's why delta is a function from Q cross sigma to Q. Uh, or and it is called transition function. So this is something simple. This is something you can say. Okay, let's start again. So delta is what? Delta is a transition function. Uh, Now some further theoretical concepts about FA as you are seeing here. If we have a state or an element Q of a bigger set, which is bigger set of states, which is Q, and any symbol A belongs to sigma, then we can interpret this delta function as delta into Q comma A. And what it means that we have a state Q, and if we apply the symbol uh, LA over this state Q, then we will move to some further state. And so that's why it is written as, so this delta into QA will give us access to some another state. So this delta QA as the state to which the FA moves. So now you will understand that what this delta QA means. It means that this is a function which will enable us uh, to move the FA to another state. So if it is in state Q, if our FA is at state Q and we have received the input A, then the FA will make us able to move on to some further state. I'm not naming that state because it is just theoretical concepts. So delta QA is a transition function. It it makes us able to move from one state to another state. This is the simple, these 2 3 lines is the simple elaboration of this delta, nothing more. So finally we can write the definition of an FA into a mathematical form as it is. For example, we can write it a finite automaton M is equal to, it is a set of 5 tuples, and the first element in that set is Q, then sigma, then Q0, A, and delta. So this is the equation for an FA, and it is a mathematical definition. So you can write this definition first and then you can elaborate what Q mean, what is the meaning of Q, sigma, Q0, A, and delta, and then you can finally say this is the definition of an FA. So here now it is an example of a simple FA for a regular expression 0 comma 1 whole star into 1 0. So what this regular is, we have to design an FA for this regular expression, or you can say a language, because now you have some advanced concepts. So now you can mix the different things. So so this regular expression is giving us clue that we can have a combination of 0, any combination of 0 and 1 in the beginning, and then the string will end up with a substring 1 0. So 1 0 at the end of the string is compulsory, and before this string, before this string, I can annotate I also uh, before this string, yes, before this string, as I am just highlighting on the screens, before this string we can have any combination of 0 and 1, and it can also null. This combination can null. So this FA, that is quite okay, but maybe some of you have a confusion over it, because this, for example, this arrow uh, is representing the direction towards this initial state. So this is our initial state. This is what? This is our initial state. So if, and at initial state, so what is the minimum string? So what is the minimum string here for this regular expression? Only this part. This can be null, and 10 is the minimum string that can be produced from this regular expression. Now 10 is a valid string. Okay, 0, and then 10 is also a valid string, and then 110, it is also a valid string. So now you have to think in this way. You have to draw your FA by considering these minimal strings in your mind. So this is my starting state, and after that I am considering this thing, this string first. So by taking from this uh, initial state, by taking 1 and then 0, I can be on the acceptance or final states. So by taking 1 and then 0, so you can draw these arrows, 1 and then 0, I can have, and then you can represent a final state with double circle. So this is the acceptance states. So and it is mentioned here that the string would be 10. So 1, after taking one alphabet, I am just labeling this state with 1, and this is 0. So 1 and 0. So this state is accepting this shortest string possible from this regular expression. And then you can consider the next one. So from this initial state, I can take this 0, I can take this 0, and then 1. So I am not at I am not at a acceptance states yet, or final states yet. So I have to take another 0, and then I can move on to the final state. So that's why after taking this 0, I am reaching at this final state 10. So this line is representing this string 010, and now I have to think for this string. So uh, I have to think and I have to design in this way. So then 110. So okay, this is my first one, and then this is my second one, and it should not be the final state according to the string. After that I can take 0 and I can reach to this final state. So that's why it's 0. So now you have drawn at least this red highlighted FA. Rest of the strings are still there. So these are the minimal strings. Now you can think further possibilities. For example, um, I can change the color. For example, from this 0 and this, for example, if I am taking 0, and if another 0 will come, I am moving here. And if another 0 will come, I am just looping here. And if I will find 1, I am moving here, but not an FA. And if I 0, then I am moving here. So this is 0, 0, 1, 0 representation. I can write it here, 0, 0, 1, 0. So this is this part. You can just double the number of zeros, and then you have this path in the FA, or you can design this path in the FA. Similarly, you can think for double 1 and 1, 0. because now this is a valid string. So 1, again 1, and for example 1 1 again 1, this is the triple one, and then taking 0 you have to reach here. In this way you already have a practice. uh, Most, for example, now you have covered all these arrows, and this one. Only this one is remaining, and this one is remaining, and maybe this one is remaining. So now you think how it is. So 1 0, which is a valid string, and if you have again 1, you can move on to here and then 0. So 1 0 is, for example, 1 0 1 0. This is a valid string. So 1 0, again 1, you can move on to this one and then 0. So this string is accepting on this path. So now it is finished. And now, for example, I can change further color. So 1 0 and then 0 1 0. So this can be another string, a lengthy string, but this is the part. Or 1 1 or 0 or 1 and then again 1. This is not the final state, and then again 0. So then it would be so more lengthier state. So in this way you can build uh, these drawings. On the right hand side, something is mentioned, and this thing is called transition table. This is called transition table. I can clear the annotation, and then you can see. This is the column representing input. This is one column. This is another column. This is representing input at the states. And these are the states, you can say. So you have to, so null is a state here. 0 1 0 1 is a state here. 0 0 0 1 1 0 1 1. All these are the states here that you have to write it here first. And what are the input symbols? 0 and 1. Now at state null, when you will take 0, where you will reach. Now at null, when you will take 0, where you will reach at 0. So that's why it is mentioned here as 0. Null, at null state, you can take this 0 and then you are reaching here. Similarly, at null, you can take the symbol 1 and where you will reach at state 1, like this. So you have to write all these, the arrows, you can say, here in this table. At state 0, which is this one, I have to clear all drawings again. So now I am thinking, this is my state 0, and now this is my state 0. So at state 0, when I will take another 0, then previous 0 and this 0. So 0 0. So where I will reach at 00. Where I will reach at 00. So